So, dear students, so let us start this concepts. So, okay, few concepts which I not covered. Okay, let me treat this. Okay, so first of all, let me start with 8051 interrupts. So, okay, let us understand first of all what is meant by interrupt. Okay, so the first point is let us understand what is meant by interrupt. Okay, so let us better understand in a technical way. You already know that we have a timer, we have a concept of timer in 8051. You know this better way. So what happens in timer? So whenever the timer overflows, for example, let us consider for this our discussion, let us consider the timer 0 in any mode. Okay, mode 0, mode 1, mode 2, whatever it may be. So let us discuss that timer 0 overflows. So for example, when timer 0 overflows, okay, what happens? So what happens? So okay, T of naught will be set. So now what if you want to generate a delay of, okay, for example, if you want to generate a delay of 5 milliseconds, what you do? So you want to monitor this flag, right? So you on the timer. So you on the timer. After switching on the timer, what first of all you configure the timer. You know this, right? So first you configure the timer using T mod, then you on the timer, then you configure the timer. How you configure with T mod, okay, th naught, tl naught. You configure this initial count and you configure the T mod value for the mode. Then you on the timer, right? You on the timer, right? Tr not equal to 1. Then what you will do? Then you will wait, right? So what you will do? You will wait for this. Okay, when this, for example, you configure the timer for 5 milliseconds. So when this 5 millisecond happens, whenever the timer overflows, right? So when it overflows, so d you will write this instruction, right? DJNZ, okay, tf naught. You will wait, right, till here. So you wait until here, right or not? So what is the meaning of this? So if tf not equal to 1, till tf not equal to 1, you are waiting in this loop. You are waiting here. So until the tf not equal to 1, you are waiting here. So when the tf not equal to 1 means the timer has overflowed. So timer overflow means this 5 millisecond has been elapsed. Okay, so this is this method is called polling method. So polling method means programmer, you are waiting, you are monitoring this flag. So your programmer, in the sense your microcontroller, is monitoring this flag, okay, until it become 1. So whenever it will become 1, it will come out of this, right? So this method is called polling. Since the event here, the event, what is the event here? The event is tf naught becoming 1. So the event of tf naught becoming 1 is being polled. Microcontroller continuously check that flag tf naught equal to 1 or not. So if tf naught equal to 1, of course it will come out of the loop. So if tf naught equal to 0, it will stay back the loop. It is continuously monitoring this flag. So this method is called polling. What is the disadvantage of polling? The disadvantage of polling is that, okay, so microcontroller is just stuck in this loop. It is not doing any useful work. Okay, so to overcome that, we have an interrupt. Okay, so we have an interrupt. So in case of interrupt, no need to write such an instruction. So whenever tf naught equal to 1, automatically, okay, interrupt occurs. Okay, interrupt is generated. Means what? Interrupt is generated, or we call as triggered. Okay, so now what is meant by interrupt? Okay, let us understand this. So in the second case, whenever, for example, tf not equal to 1, automatically, okay, interrupt is generated. Means what? Like your CPU can be doing some program, right? So CPU will be executing a program. So for example, CPU is here executing some instruction, interrupt occur. So interrupt occurred means here tf not equal to 1 means that interrupt occurred. So what happens? So your microcontroller temporary halt the main program. Suppose this is the main program. your microcontroller temporarily halt the main program. Okay, it will jump to some other program. Okay, this some other program is located in some fixed address. Okay, in this case, okay, this some other program is located in address called 000BH. Okay, so it will jump to this address and execute the program present in this address. Okay, execute the program present in this address, right? Then at the end of this program, we'll use this instruction called return I. Okay, then after executing this program, then it will again come back and execute the program, right? So what is this? So whenever an interrupt occurs, the flow of execution of the program will be shifted to the one fixed address. This fixed address is called vector address. Okay, and for this interrupt, to serve this interrupt, okay, so in this case, to serve this, generally what we do, whenever the timer overflows, maybe suppose if you want to generate a square wave, what we do, so to whenever the interrupt occurs, we will toggle the particular bit. For example, we complement some port, complement some P1.0, something like that. So we want to generate a square wave. First we will, okay, generate the 0, then we generate a 1, then we generate a 0, then we generate a 1, then we generate a 0. So this delay we are generating with the timer, right? So whenever this delay has passed, automatically Tf0 become 1. Whenever Tf0 become 1, okay, come to this program, complement, make it as 1, okay, and again return to the main program, do its work, right? So again, okay, timer will start counting. So after the delay again, okay, again interrupt is generated, then again come to this program, complement, make it as 0, okay, then again make it as 0, again return. So this is what interrupt is. So in this case, no need to monitor for the event. Whenever an event occurs, automatically an interrupt service is generated. So this program, whichever in response to this Tf equal to 1 event, this program, whichever this program is called what? This program is called interrupt service routine. So okay, this program is called interrupt service routine, or we call it as interrupt handler. Okay, we call it as interrupt handler. Okay, so this fixed address is called interrupt vector address. So interrupt vector address. Okay, so simple concept, just remember that. So whenever interrupt occurs, so that particular, it is the program will be shifted to one particular address, right? Then it will execute this service routine, then it will come back and execute the normal sequence. So how you may get that out, right? So how it will come back again, so it will jump here, okay, so how it will come back here? See, definitely you know this, right? So just understand this concept, you might have studied in the CO. So how it does this? So suppose this is in the main program. Suppose the main program has some 5 instructions, okay, instruction 1, instruction 2, 3, 4, 5. Suppose the microprocessor is executing this instruction, your PC will be pointing to this instruction, right or not? So PC is always pointing to the next instruction. Okay, so what happens? So whenever suppose it is executing this instruction, an interrupt occurred. For example, Tf0 became 1. So what happened? Okay, so microcontroller will complete this execution. Then what happens? This PC contents will be saved to the stack. Okay, will be saved. Saved means push this PC contents to the stack, right? Once it pushes this PC content to the stack, then what it will do? Then this vector address, that is called 000BH, this is the vector address for this interrupt Tf01. So this vector address will be put into this PC, okay, put into this PC. So what happens? Automatically it will jump whenever your program will jump to this address. Okay, so this address is copied to PC. Okay, then this will start executing. So whenever it sees the return I instruction, what happens? Return I stands for return for interrupt. Okay, so whenever it sees the return I instruction, what happens? Automatically the stack contents. So this, whatever this address, next instruction address which is pushed to the stack, that is again popped and put back to the stack, put back to the PC, from stack to the PC. Then it will come here, so then it will come here. So like this, by temporarily saving the PC contents into the stack and putting the vector address to the PC, it will jump here and execute the ISR. ISR means service routine. So this is ISR, interrupt service routine. Okay, it will execute the ISR, and again whenever it sees the return I instruction, it will come back. It will come, how it will come back? Just pop the address from stack to the PC and come to this instruction and start executing the main program. This way this interrupt is handled. This interrupt handled happens. Okay, just the next whenever this interrupt occurs, the next so the current instruction is being completed. So meanwhile it will save the address of the next instruction in the stack, then put the vector address into the PC so that it will jump to the ISR, execute the ISR, again return to the, after executing at the end of the ISR will use the return I instruction. Whenever it come across a return I instruction, it jumps back to the main program. Okay, how it will jump? Just pop the address from stack to the PC and jump to the main program and execute the main program. This is what happens. So in 8051, how many interrupts are there? That is the next question. So 8051 has 6 interrupt sources. Okay, 6 interrupt sources. What are these interrupts? Okay, so 6 interrupt sources. Okay, so for this, the first interrupt is reset. Reset. The vector address for reset is 0000H. Okay. The next interrupt is TF0, that is timer 0 overflow. So for this the vector address is 000B. Okay. Similarly, the third interrupt is TF1. This is a timer 1 overflow. This is 001BH. This is a vector address. Then the fourth interrupt is the INT0. Okay. INT0 is nothing but some external interrupt. So I told that microcontroller has 2 pins. Okay. 8051 has 2 pins called INT0 and INT1. So some external factor, some external device is interrupting, like external sensor or some external some other PC or some other microcontroller, whatever we connect to this pin. So that will get interrupted, or some switch. Okay, that will get interrupted. So that device is interrupting the microcontroller for providing some service. For example, you assume that this is a lift. 8051 is controlling some elevator. So you press a switch, right? So that is indicated to the 8051 microcontroller via interrupt. So that is an external interrupt. Okay. So for this, the vector address is 0003H. Okay. Similarly, for next interrupt is INT1. For INT1, the vector address is 0013H. Okay. Finally, the sixth one. Okay, both RI and TI. Okay. So you know that RI and TI means whenever we use this in the serial communication, right? So RI stands for whenever we receive a bit, RI will become 1. Whenever we transmit the bit, TI will become 1. So this events also both has a same interrupt, one interrupt for serial communication. That interrupt address is 0023H. Okay. So these are the 6 interrupt sources: reset, TF0, TF1, timer 0, overflow interrupt, timer 1 overflow interrupt, external interrupt 0, external interrupt 1, RI and TI, serial communication, receive interrupt and transmit interrupt. Okay. So these are the vector address corresponding to each interrupt. So whenever that particular interrupt, for example, whenever INT0 occurs, your microcontroller will automatically execute the program located in the address 0003H. That is the meaning of this vector address. So whenever the timer 1 overflows, automatically your microcontroller will execute the program present in the address 001BH. That is the meaning. So that's why whenever we reset the processor, your microcontroller will start executing from the 000H. That's why we start writing the program from 000H. Okay. Also you note that, so whenever for all these interrupts, okay, for all these interrupts, so whenever, for example, if TF0 equal to become 1, so after servicing this interrupt, automatically TF0 will this happens automatically, TF0 will become 0. So when TF0 become when TF0 become 1, this interrupt occurs, so it will jump to this program and execute this program. After executing this service routine, automatically TF0 is cleared. This will happen automatically for all these 5 cases. Okay. But in case of RI and TI, once TI, for example, TI equal to 1, then as a programmer we need to clear this TI equal to 0 for handling the next interrupt, right? For example, suppose I want to transmit a 2 characters. For the first character ti equal to 1, fine. Then we as a programmer we need to make ti equal to 0. Then again we transmit the character, then again after transmitting ti will become 1. So this the process of making from 1 to 0, this as a programmer must do, but for this thing it automatically happens, right. So this is a point you remember. So the next important point is whenever we use whenever we use the interrupts in our programming, you just follow this template. So org 000h, okay. So we start, okay, just use, don't write any extra thing here, just use this instruction lgim to main. So as you can see here, the address range from, okay, you can, if you observe carefully here, the address range from 0000 to 002f is reserved for interrupts. So okay, so this so better you start writing your program, you just jump to the main program, right. So in the main program you start from the address org 30h, right. So since this address is reserved for writing the ISR, ISR stands for interrupt service routine, interrupt service routine or interrupt handler, okay. Better you start writing the main program from the address 30h, okay, you write the main program here and end. So this is a template, please follow this template. Whenever you use the interrupts, please follow this template, okay. So that's it for this video, thank you.